So this talk I'm going to give is about how and why we're building this machine learning platform internally inside Uber. So this is roughly the agenda. Based on a lot of machine learning, based on a lot of machine learning applications we see internally, we see a lot of common practices, and also we see a lot of common pain points. So that's why we start thinking about building a machine learning platform as a service and to serve the Uber needs. So here, as the early days, when we see a lot of data scientists, a lot of different product groups, they start doing machine learning applications. Usually they follow all these steps. So in the very beginning, they take a lot of laptop time trying to clean up all their data, collect their data from all different sources in all different formats, in all different ways. Some of them are batch mode, some of them are streaming. They have to pay a lot of attention to get them ready. And then they start doing training. And in early days, again, it's a very, very ad hoc. There's no rules. People choose whatever tools available to their hand. So naturally, the training environment is also it's not homogeneous. People need to get into the environment they're familiar with. They want faster iterations on top of it. And eventually, after the model is trained, they need to do evaluations. And evaluations, most of them are very standard. So for example, if you're doing a binary classification, usually you run AUC, you generate ROC curves, you separate your data set into train and validation, so on and so forth. And some of them are very, very customized. So for example, we have image classification problems. There's a bunch of image segmentation questions. People, if only doing those standard classification, it's not really readable. So people have to think about, how do I visualize it? I need to draw the image. I need to put the segmentation layer on top of it. It's a tedious work if, as a scientist or as an engineer doing your own work, you don't want to think about, in JavaScript, how do I draw a triangle on top of an image? So that's why, from platform point of view, we want to provide something which is very generic, and then it can support all these standard ones and those customized ones you have. And then talking about productionize. So when you deploy your model, now it's a totally different world. You're talking about versioning. You're talking about, my model should be scalable to serve all the traffic I see. It becomes shifting to the edge side quite a lot. And for sure, the core is why you are doing the modeling. You want to do inference. You want to score something. And all these things, then we start talking about how we're going to score them. You need to score them sometimes in the batch mode, sometimes in the online mode, like regular server, client-server query pattern. Then we need to build monitoring on top of it, because we want to know what we're serving. We don't want to serve garbage. So that cannot be missed. So based on all these requests and all these common practice and similar for those things, the common pain points, that's why we work there. We started this project internally in Uber. Our goal is really just to enable engineers and data scientists across the whole company and make sure they can easily build and deploy their machine learning solutions at the scale Uber needs. So on our side, this is more or less as a service what we should provide. So first of all, it should be a scalable infrastructure for both training and serving. And machine learning itself is a very wide spectrum. On one side, it's data scientists, it's engineers playing with the system, trying to understand and find their solution. So they need a prototyping tool, fast iteration. On the other side, it's a production thing. When model in production, it needs to be very scalable, very stable, and make sure you're making predictions correctly all the time. So then we want to make sure our model can be serving all different types of patterns, batch mode, online mode, but we don't want to limit our users too much. So in our system, we provide most of the traditional ML trainings, we provide deep learning. It's definitely a trend coming. And different modes like supervised learning, unsupervised learning like clustering for sure. Online learning is one thing coming. So it's actually still in the debating stage, whether we want to support it or not. So as a product, just a highlight to an internal user, it's more or less what you see. This interface more or less highlights the stage or the step when you're doing your model. So you have to do your data sources first, and then you start thinking about some training. So you build your models. After you build your models, you can run a bunch of evaluations on top of it, and then you make the decision to deploy them. After the model is deployed, you can start making predictions. It could be either online or offline predictions. So I'll use Uber Eats as one example and as one use case, just trying to highlight how do they use this system in different stages. And based on those, we're going to highlight some questions they're seeing, some tough points they're seeing, and tell you how we're solving these problems. So this question is, if you use Uber Eats, it's pretty popular in the city over there. I actually use every weekend for my family. Usually you end up with these two different screens. In the very beginning, you can scroll, you can browse through, you can scroll through. There's a lot of restaurants you can choose from. For each restaurant, there's a time attached to it. What that means is if you place an order, from the time you're placing the order till the time you receive your order from your home, how long it will take. So there's a time estimation on that. And when you press the button, say, I place the order, then you actually can see a progress bar. What's going on for my order? I have different stages. Like the restaurant accepted your order, they start preparing the food. Food is ready, and the driving partner is picking it up. It's on the road, it's coming to your door. So to answer all these things, it's actually a sequence of linear regression models under the hood to making predictions. So from modeling side, it's not really that crazy. It's not too much magic. It's just regular GDB trees doing regressions. But the interesting piece, I would say, too, what is the features? Where the feature coming from? And another one is, as you're doing production, you have to make sure you can do experimentation. You want to choose which version you want to deploy. So I'll start from the feature side. For features, I would say there are two types. One is, I will call them easy feature. The other one, I will call them hard features. So the easy features are those features very convenient by the user, just by their hand, when they're making the call to us. For example, where I am, at the time I'm making the order, my location, the light-long location, those are very easy. They can just find them along their code path. When they receive their request, they will have it very naturally. Some of them are actually hard, usually those aggregated features. So for example, I want to know for this particular restaurant, how many orders they have served in the last week, last 7 days. Unless you have a pipeline trying to aggregate this one, you cannot have that easily. So we call those curated features. So the key challenge here is, the training is usually happening in the batch mode. And the serving, in this particular case, as a user, press the button, they make the call to their backend. And their backend take this request and send the request to us, and we serve that immediately. It's in the online mode. So the training and the serving is not actually in the same environment. This online serving and the training is totally different technology stack behind the scene. I'll show that later. So then the question is, in such a two different system, how do you guarantee the data is synchronized between them correctly? And then sometimes actually not exactly the same. You have to be really, really careful. And training and deploy is actually happened at the city level. So it's not too, it's sort of intuitive. Because different cities are gonna have different patterns. They're serving different people locally. You cannot just say using Brazil data, Sao Paulo data serving San Francisco. People just having totally different living patterns. Then from production point of view, it needs to be easy. You don't want other side of your customers in this sense. I mean, other teams think too much about how do they deploy. After they train the model, they're happy, they should be done their work. So, and then we have to have this monitoring keep going on, make sure your model is doing the thing you're expecting. So let's go just deep dive into those questions one by the other. Let's start with the training and predict. As I said, it's coming from totally two different stacks. Training is happening in the batch mode, and in this particular case for eats, the prediction is happening in this online mode, like one by one query. So the data access pattern, if you're talking about the easy features, it's actually okay. I don't care too much because in both ways, people can provide them to us. It's up to them how they're preparing them. The really hard part is I call those hard features, those curated features. If you look into them more carefully, there are actually two types. It's not exactly the same. Recall the two questions I was thinking about. One is how many meals a particular restaurant prepared in the last week. And the other one is how many meals the same restaurant prepared in the last 30 minutes. So they have different data freshness. This is a per day thing, like per week thing. I can just compute them daily in a batch mode. With that small shifting in the day, my data not going to stale that quickly. So I can just compute them in a batch mode. But think about the data, the last 30 minutes, it goes away really, really quickly. If I want to do them in a batch mode, it's like insane. You have to rerun your batch in the very high frequency. So indeed, as we're doing the work under the hood, it's a Cassandra, it's a streaming pipeline to do that we call near real-time feature. And talking about the query patterns, it's actually also different. We are doing a batch mode to optimize your throughput. We use like HDFS, Yarn, Hadoop, Spark, those very typical batch mode tools. All the files, like Parquet files, are highly tuned towards this batch mode. It's never going to work if you want to do a random index query on your Parquet file. It's insane. So to do that, the online query part is actually a random query. It's a key value pair. So like say, I have this restaurant, it has a key. During the serving time, I need to access this restaurant, tell me what's going on. So this is a standard, like a key value store you need to store somewhere. So in this sense, we use Cassandra Store for this particular purpose. Then it definitely introduced how do we do the data synchronization between the Hive part, the Parquet file part we have, and the Cassandra part we have. And for data access itself, it's also interesting. So back to that easy feature and hard feature we have. During serve time, if you want to say those easy features, it's easy. It's coming with your payload. But for those hard features, you have to tell us how you want to query this Cassandra database to pick it up for you. So you need a key to refer to it. So to serve this purpose, we actually introduce a like in-house DSL, domain-specific language, just to do another round of feature engineering right before those features get into your model. So here are some examples. For those base features, easy features. So here, it's basically saying, I'm interested in this particular feature from the input, and I'm doing impute. If this feature does not exist, if it's a null or something, I'm going to fall back to the column value of that one, and I'm treating that as a numerical value. Oops. And this is just the other case. If this is a hard feature, the curated features we have. So here is more or less saying, this is a curated feature, and I'm interested in restaurants, their orders, preparation time, average in the week, and the way I'm going to query that is by their ID. So after you have your data ready, now we're talking about building the models. As I said, it's very typical in Uber because we're running in different cities. Different cities have different data patterns. So we have to train the models at the city level. So after the model is trained, you want to make sure you can deploy them, deploy all the models you have as a one logical thing to your whole system. When you talk about productionize, you need to think about rolling upgrade and downgrade, rollback if necessary. So all these things need to be version controlled. But first of all, let's talk about how to train the model. To train the model, you need to do two things. Basically, we introduce, so first of all, get your data ready, and then do the training. So to do the training, more or less, we introduce this hierarchy. And this hierarchy is actually manually curated. So, because they know, for example, in the East case, their data scientists know it's okay, I use the global one, if then I can subdivide them, partition them into country level, and then based on the data, it's good enough, we can just sub-partition them into the city level. So it's up to the user. They can say, no, in my case, I need the regions. So like I need West Coast, I need the East Coast, so on and so forth. It's all in their hands. But to us, it's nothing special. It's just a tree structure. Then even the data split, you need to be really careful. So it's a very common practice. You do your, you split your data for cross-validation. So you have your training data, you have your validation data. You pass both of them to your training engine, make sure you're not doing overfitting, so on and so forth. So by definition, because in every single level, you don't want to leak your information between the training data set and your validation data set. So by definition, all this split, you should have your random split at the root level, sorry, at the leaf level, city level, and all the parent level is a union of their training set or validation set, just all the way up to the global, up to the global model. It's mathematically, it's very easy. But if you're talking about training such a thing, doing such a thing with a huge amount of data using Spark, if you're just simply doing union, you just screw up the whole cluster. It's never going to process as the way you're thinking about. It's super, super slow. So it's a lot of dirty details, how you do those Spark tricks, make sure all these things can be handled properly. It's actually on our plate. To the users, to the customers, they actually don't need to worry about these details. That's part of the platform should support. Training is nothing really special. So based on the data set, the size of the data or the pattern of the data, we decide, oh, this particular city is too new. So in this particular training run, we're not going to train that. It will fall back to its parent model. Then all these highlight models are serving the real traffic. So in the next round, when the data is more, then maybe this city will just become independent than all the models serving in the root level, leaf level. Then after everything is ready, you have your model. Now you're talking about deploy them. So when we're talking about deployment, it's first of all how we're going to use them. So this particular case, as we said, it's an online type of thing. People sending the request to you. Internally, this is more or less standardized in Uber. It's a RPC request from one service to the other. So some special thing for us is our RPC service is basically a container which can run one or multiple models. The way to scale them out is actually also very standard in Uber. So whenever you want to build such a service, you need to, during deployment time, you build your binary into a Docker image, and the Uber infra gonna ship your image into the hosting machines and control all those, like running those instances, running those containers using Mesos. It handles all these single and multi-tenancy, like data center problems for you. It's all done by infra, so we're not doing it. We're relying on even lower level of structure to support us. Something special for us is that to the Cassandra. I mentioned that in order to support those curated features, we actually host them in a Cassandra database. Now the question is, usually when one record coming in, it's not going to use just one single Cassandra feature. It's going to use a bunch of them. So we cannot just simply fan out all the requests to the Cassandra, because basically they're going to X multiply your own QPS to your QPS to the Cassandra database. You're going to explode the other way. You're going to bomb the Cassandra thing. So we have to do the query optimization. But the lucky thing is, during deployment time, your model is already frozen, it's stabilized. So you already know every single query pattern from every single model based on the DSL we defined. So we can optimize all those query patterns before we're serving any drill traffic. And when the record is coming, we make sure we minimize the number of calls we're sending to Cassandra and redispatch all those features at the record level for serving purpose. So deployment, again, it's nothing done by us, I would say. It's really heavily supported by the Uber common infrastructure. But to facilitate them, we need to use the infrared. So for example, we need to provide health check. We need to know how well the system is. And then this can facilitate them to doing the rolling upgrade and if necessary, the rollback immediately. That give you the service quality you need when you productionize it. Then after the model is deployed, you want to make sure two things. One is your model is serving. Are they just crashing, melting down? Two, are they serving the right things? So there are two different things. So whether I'm service is melting down, think about suddenly in Halloween night, I get a peak of the traffic. So in those cases, if you don't take extra care about the host you have, you actually can run out of, you can crash. You're melting down the whole service. Then you introduce outage immediately. That's horrible, horrible, horrible thing. So you want to make sure you set up all those latency, like QPS things, make sure you're monitoring your system properly so that when you can roll back properly, then human beings, like engineers will jump in. Another thing is performance-wise. So interesting thing in Uber, most of the Uber application is eventually you're gonna know the truth. So basically if I say I make this estimation, after the food is delivered, you immediately know the answer. So we can just sample a bunch of data and eventually compute a performance out of it, and you can have a continuous evaluation on your model. So for example, if it's a standard time binary classification, you can plot your confusion matrix at 4 cells as a time series, then set up some signals on top of it, then you can control your models. So just recap, to glue all these pieces together, how do we do it? We have this Spark thing. It's doing training, doing all the data prep. And then if you want to serve your model, that's not too hard. It's in the same environment. Then this data prep thing, curated feature kicked in, doing the features we need. And then if you want to serve, it will be shipped into your online infrastructure and the Cassandra side to make it work as well. So, and at the end, we're taking it back, make sure we're monitoring what's going on. So that's more or less it. Thanks.
So, thank you for the presentation. Do we have questions?
Hi, thank you. One thing I was thinking about while you're describing the DSL is, do you have also in this DSL the capabilities to define a new custom feature, or just to query the features that are already created? And if you don't, how is the process of creating a new feature? How do you go about checking what do your user need to have in your database and creating the new feature?
So usually the features we're creating in that curated feature store, it's a very, very basic ones. So our DSL not only doing these queries, it's actually going to give you some data massage ability as well. So basically you can say, I'm using my curated feature A plus curated feature B divided by curated feature C, and multiply my base feature D, so on and so forth. So you don't really need to, for every single thing, curate them in your feature store. If it's something totally special, we actually do have to modify our ETL pipeline so that we can record the new features. And we're actually open the door to the customers. So we give them the easy way to register their own ETL into the system. So then everyone, if they want, they can register their own features into it. And we're trying to standardize that. So different teams can actually sharing features. But there's hard questions. Who is going to own them and who is going to change them? So it could be messy.
We have more 2 questions.
You said that sometime in the future, you know when a prediction is wrong, right?
Mm-hmm.
And how do you backtrack that to the request at first? Because there's a lot of little systems in between it.
Mm-hmm. Yeah, it's also a common practice in Uber. Usually all those things, all those events you're sending out, it becomes a Kafka topic. And we have this centralized aggregator. They eventually will consume all those Kafka topics back to this data lake, this Spark side thing. And that's how we figure it out.
One last question.
So actually, 2 questions.
Mm-hmm.
The first one is, how do you serialize those models? So are you serving Spark models directly? What type of things you're doing to serialize? And how long did it take to build all the data platform, the ML platform? And how much of it is open source? How much of it is internal technology?
Okay, so serialization, deserialization. Let's say we're actually serving different models. The typical ones we're serving is XGBoost models, MLlib models, and the TensorFlow models using GNI. For serving all of them, if you track all the way down, they're doing some serialization by themselves, like, for example, protobuf in all these 3 cases. So we have a packing logic, more or less just treat whatever you have and then pack them as a jar file. And then this jar file get delivered through the methods to all the hosts. And our container actually do have this smart enough. During the serving time, they know each jar is supposed to be separate. It's in some sense like a Tomcat server. All these things, all your models are like servlet, just isolated from each other. That's how this serialization, deserialization things. The second question was, can you repeat the question?
How long did it take to build the machine learning platform?
So machine learning platform is actually an ongoing effort. We're iteratively building it. It's starting about 2 years ago, exactly the same time right now. So it's still evolving. We're starting from building batch mode and then talking about this online mode, and more other surrounding features are actually coming. Open source part, we don't really build all those training engines ourselves. We're sort of gluing pieces together. But we do a lot of infra thing in the middle, make sure we can control this, like you have so many different things under the hood. You don't want them to explode you. So you want to isolate their changes from your changes.
We still have time for more couple of questions. We have more questions.
So it looks like you do lots of batch offline processing,
Mm-hmm.
mainly in the feature engineering part. And at the DBMS level, do you prefer to have a schemaless store for the features so you can easily add or remove stuff, or do you prefer to stick with the data integrity with the relational databases?
We use Cassandra, so more or less what we're seeing is a bunch of columns, and each column is typed. It's either a string column or a numerical column. So, because if you trace all the way down for the training, ignore image processing and part of text processing, it's either numerical or categorical. So that's where we control the schema. We don't want to hard code our schema to the business content. Say, we don't want to introduce a schema. The first column is the number of days. The second column is the average food preparation time. We are not at that level, so it's going to be too restrictive.
Hello. As I've seen, you have a heterogeneous environment using Cassandra and Hive and so on, and an heterogeneous workflow. And maybe sometimes you to communicate the lessons learned of projects and models and so on, you need to have trackability. Airbnb is doing some software about it, such as Airflow and Data Portal, to track the data and democratize the data set and so on. Because I believe there is some interchange between models and between knowledge per se that you can grasp by reviewing what the other data scientists and data engineers did in different models and different problems. Do you have any project on that direction?
Two things. So one is knowledge sharing. Usually, we do two types of things. One is the whole workflow. As we said, the common steps for building a model is not so variant. People collect their data, so on and so forth. So every single step, like how you collect your data, it could be a DSL, or it could be a particular Spark file you can land in the code base. So that's one way we share the knowledge. And another one is the DSL itself. So our feature engineering is actually, I would say, twofold feature engineering. The first fold is you do that at your data prep time. It's very expensive. You don't want to repeatedly doing that too often. The other one is this real-time, on-demand feature engineering. That happens at the role base. It's supposed to be fast and cheap, but usually it gives you a lot of real tricks. So that's another way people can share their knowledge. Also, the model configuration is also available to other team members in them. So there are some permission control things on top of it for sure, but they can see each other. Then the second part, the workflow itself, you mentioned like Airbnb, the Piper workflow, so on and so forth. It's actually an ongoing effort from us as well. Because in the beginning, we really be very rigid. We say you have to follow this exactly workflow to make sure everything's done, even though it could be different jobs. Eventually, we learned actually no, it's not always the case. So we're actually thinking about opening the door. People can defining their own workflow, but still under control. Because when you open that door, then the question is how you make sure your different node in the DAG is compatible. If it's not compatible, user will be so confused. How come my things never can be connected together and your things working? It's from us point of view, it's very hard to explain to users unless you have a very, very good type to define all the interfaces in between.
Any more questions?
So you said you collect all those monitoring data on Kafka, and yesterday there was a talk about people using machine learning to do monitoring. Do this data come back to the same infrastructure and can be used by infrastructure team to monitor what's happening?
Yeah, it's a very good question. Indeed, the very beginning, before this team was formed, the very first data scientist question we're trying to solve is what you said. We're trying to detect some anomaly for our infra and trying to make predictions on top of it. And we learned so much crazy things. Yes, it's happening, but it's actually a huge, very, very complicated question. This data scientist question itself, it's really hard.
More questions? Okay, I have a last one. You have said that a key part of your mission is to provide a scalable solution. In the point of view of Uber, what is a scalable solution? How do you know if something you are going to present is scalable enough or not to be deployed?
So your question is how we make sure the things we have is scalable, right?
Yes.
Okay. So I don't think it's a like Uber question. It's a common infra question. You have these two modes very commonly. One is this serving time. When you're building services, you need to make sure most of the time your service should be stateless. So it can be blindly scale up horizontally just by adding more and more machines without thinking too much. So that's how our serving part is. And batch mode part more or less follow the same trend. So even if you're doing Spark, you want to make sure there are not too many hidden constraints about how many nodes, how many workers you need. There shouldn't be too many constraints about how many workers can come up and down. So all those things, you have to choose the tool properly, make sure the tool you're selecting doing the right work for you. That's more or less it.
Okay, let's thank our speaker for his inspiring talk.